welcome. Really happy you could be here. We're here for the computer science information session for the Fowler School of Engineering, or more generally our computing program, since we have a few that are very closely related, including computer science. I'm Eric Lindstedt. I'm the Senior Associate Dean here at the Fowler School of Engineering. I am joined by our Manager of Student Success, Miss Adina Hamlin. And this is, kind of one of our favorite things to do. Hopefully in the next few minutes, you'll be able to see that we're pretty excited about the way that we approach engineering and computer science at Chapman, and we have a lot of good stuff to share with you. That being said, I think Adina and I are a pretty informal group. So you are more than welcome to turn your cameras on. I have some charts I'll be talking to, just because otherwise I'll be too scatterbrained. But that being said, you're more than welcome to interrupt me at any time to ask questions. Adina will be monitoring the chat. This really, the hope is at the end we'll be able to certainly have a dialogue, answer any questions you have, talk more about why sort of we think we get engineering education and computer science education right at Chapman. At least that's the idea. So if that sounds okay, I do have a few slides, not too much, but I think it's a good highlight, and we'll sort of dive into it. I'll tell you a little bit more about myself. I'll tell you a little bit more about the programs that we offer in computing. And then, I want to sort of talk a little bit about what I think it means to be a computer scientist or someone who really pursues computing as sort of an intellectual discipline and also as a career, and sort of how in my life, even though I went into computer science sort of thinking I was going to have a very traditional technical career, I think it's really opened up some doors to do things that I hope have broader societal impact. So I'll talk about that a little bit, and then, like I said, plenty of time to answer questions, but don't be shy. Turn on cameras, come off mute, yell at us, post stuff in the chat, and we'll hopefully have a good hour or so. Okay, now we will take the big leap and see if the technology will actually work. Your guess is as good as mine. Okay, see that. That. Okay, hopefully you are seeing something. Yeah.
Yep, we got it.
Perfect. I love it. If I've accomplished nothing else today, at least I got this going. Okay, let's do this. Let me know if you're still seeing this.
Got it.
Wonderful. All right, so we can get started. So like I said, I'm Eric Lindstedt. I'm the Senior Associate Dean in the Fowler School of Engineering. And as I was sort of prepping for today, I was thinking about the points that I really wanted to hit. And I know that those of you that signed up, most of you suggested that you're interested in computer science. And so, yeah, I'll tell you all about our computer science program, our related programs. But I was trying to kind of just think a little bit more broadly and a little bit more deeply, and just why I think that this is a really great time to get into computer science, software engineering, data science, and how I think perhaps people don't give it the discipline, the credit it deserves in terms of being able to make a social impact. Certainly a lot of excitement right now in terms of technical impact, with computer scientists finally winning the Nobel Prize and things like that. But I also think this is an opportunity where we can do right for our fellow citizens of the world. And so I didn't want that to get lost in the presentation. So I apologize for the cliche title. I promise we'll still cover all the nuts and bolts of computer science at Chapman, but I just didn't want this to be another, yes, we have a computer science program and here's how you graduate in 4 years, although clearly that's something that's important to you all. So a little bit about me. What's there to know? Well, a couple of things. One, I am a computer scientist through and through. My bachelor's, my master's, my PhD are all in computer science. But I think probably more important, I'm a first generation college student, and I'm actually a product of the computer science program at Chapman University. Granted, it was a million years ago. I was class of 2001. But I really sort of give credit to my Chapman computer science education to setting me on a good path for success. So after Chapman, I did my master's at Stanford in computer science. And then a little bit after that, I did my PhD in computer science at UC Irvine. For me, I think computer science was something that really just kind of clicked with the way that my mind works. In general, if you like problem solving and you like the ability to take a big complicated problem and sort of break it up into pieces and solve those pieces, and then by doing that solve the bigger problem, then computer science, software engineering, anything related to algorithms is probably something for you. One thing that I feel very strongly about, and one thing that I think that people sometimes often get wrong about being a computer scientist is the number of hours per day that I spend actually sitting behind a computer writing code is relatively small. These days, everything is data driven, everything is compute driven. And so most of my time, I think I actually get to spend working with people in other disciplines, trying to work on challenging problems, hard problems that I really genuinely believe can change the world. And so for those that maybe your only exposure to computing has been in a programming class or something like that, it's much broader than that. And if you'll sort of give me a few minutes to try and convince you of that, then that's sort of one of my goals here today. In addition to being a first generation college student, I am also a first generation American, which surprises folks, but it's true. My dad's side of the family is from Canada, but my mom's side of the family is from Italy. In fact, my uncle came out here first. He started an Italian restaurant in Lakewood, California. That was sort of the mechanism that he used to sponsor everyone to come over and immigrate to the U.S. And so I grew up in his restaurant and got to learn a lot of good things. I mean, one of the things that I definitely learned from being around him is no matter what you do, if you put people first, then you're probably going to have a very fulfilling life and you're going to be able to make a difference. And I think the other thing that I learned from him is that it's really important whether you are making pasta or writing computer code to sort of give everything your best effort and learn from your mistakes. So I was lucky to have him as a mentor growing up. And certainly, as a first generation college student, thinking back to the lessons I learned in his restaurant helped me get through. Certainly, he was a big inspiration for me wanting to go into computer science. I think when you're a first generation American, sort of the things that are sort of told to you is you shall grow up and you shall be a doctor, a lawyer, or an engineer. Can't stand the sight of blood. Law seemed like too much reading for me, and so engineering seemed like the best option. And the other thing that my uncle always told me is if you get yourself a good education, then ultimately that gives you the opportunity to take risks and have the ability to fail and know you'll be able to get back on your 2 feet. And so I owe my uncle a lot in terms of the way that I've approached my career and some of the fearlessness that I've tried to approach it in, although sometimes, admittedly, I've been more fearless than others. I'm the son of a veteran. My dad was a Vietnam era veteran, didn't go overseas, but at least it wasn't in combat duty, but he was serving in Germany at that time. And certainly his experiences after being discharged out of the Army have definitely influenced the way that I've tried to help encourage things in the School of Engineering to be inclusive. We really believe that engineering is for everybody. It doesn't matter what your background and circumstances are. It doesn't matter if you're a traditional student that's coming right out of high school. It doesn't matter if you're coming from a two-year university. It doesn't matter if you're in your mid-20s or older because you've been serving in uniform. Fowler's a place where you can come and really interact with everyone and be welcomed, which is certainly very different than the reception that my dad got when he tried to get into higher education after separating from the Army in the 60s. So again, if you're looking for a place where you can study computer science, software engineering, data analytics, and be part of a broader community that actually cares about you as a person, I think that Chapman is definitely a place where you can do that. And I think that's based on many of our sort of our own personal principles of the faculty and staff as we've built out the school over these last few years. Um, I am also actually not a dyed-in-the-wool academic. I spent quite a while in industry. I have about 20 years of industry experience under my belt, first at Boeing and then at the Aerospace Corporation, where I still consult when they let me. I've been lucky to work on really cool things from next generation Navy destroyers to future combat systems to satellites that are still above us right now in geosynchronous orbit. And so I thought this was important because I think a lot of times when we're talking about computer science, everyone just assumes that we're going to write code that's no one's ever going to see. You're not going to build things that you can actually feel. That's absolutely not true. I'm a computer scientist, but first and foremost, I consider myself an engineer. And I personally believe that engineers at their heart are builders. I think that, like many of the faculty members, my experience in industry has helped to develop, a more robust computer science curriculum and helped me be a more robust computer science instructor. At the same time, when I was in industry, I think the ability to teach and explain problems, really helped me be a better engineer in terms of communication and those soft skills. So my overall career has been very non-traditional, but it gets back to a couple of things. One, computer science has served me very well, and I've been able to do pretty much lots of different things and reinvent my career because of having a good background in computing. And then two, some of the best things that have happened in my career have actually been happy accidents and things that I really couldn't have planned for. And so, regardless of ultimately what you end up studying or where you end up studying it, the advice that I will give you, and I hope that you will take with you, if nothing else, is keep your eyes and your ears open because opportunities will come in very different shapes and sizes, often when you least expect. Um, Probably most importantly, in addition to all of that, I am a dad. I have a now 15-year-old daughter named Hannah. In the middle, she is there with her service dog. Hannah is inquisitive, funny, sarcastic, witty. Now she's a very snarky teenager, and she is also on the autism spectrum. And I'll talk a little bit about that later, but actually, in terms of strange and happy accidents, her being diagnosed with autism was something that really caused me to blaze a new trail for myself in my career as a computer scientist. But anyway, that's basically me in a nutshell. So hopefully now you know a little bit about me. You don't just think that I am the college equivalent of a car salesman that's trying to show you a shiny brochure. I've been at Chapman about 22 years. I've pretty much spent my entire adult life here, and so I very much believe in what we've built in the School of Engineering and the programs that we built, like computer science, that have been around since 1978. Long before that. So this is, my life's work, not just, something that I happen to be doing in the moment because it keeps a roof over my head. Speaking of roofs, though, this is Swenson Hall. These days, as an academic, I get to come here and work every day with awesome people like Dina. We laugh a lot, and I think that's another really important thing, whether you study engineering or computer science or anything else. If you have a job where you can go and chuckle and be around like-minded people who challenge you to be better every day, then that's a really great thing to have in your career. And I certainly have that, and I'm grateful for it. Um, Okay, so sort of enough of the sappy nostalgic stuff. So presumably you're here today because you're interested in computer science, and we certainly do have a wonderful Bachelor of Science program in computer science. I also want to say that we have some related programs, in particular data science and software engineering, which are other undergraduate majors that we have that are highly computing oriented. And so while computer science is certainly a traditional degree where you focus on data structures and the creation of algorithms, we have software engineering that I would say uses all those skills to actually be able to build systems and systems of systems in the industry, and data science, which uses computation to find patterns in data. So curriculum-wise, they're all very much related. They have slightly different emphases, but both have a heavy computing or all have a heavy computing and algorithms sort of foundation. In addition, recently we've added a new Master of Science in Electrical Engineering and Computer Science. And the reason I mentioned that is because it's available as an integrated degree. And so if you complete your undergraduate degree at Chapman, and you come in well prepared, then you can basically start graduate coursework in your senior year and then complete your master's in one additional year. So 5 years total, you can get a bachelor's and a master's for those who are interested. So a lot of our students are excited about that. Last year, we saw pretty close to 20% of our graduating seniors choosing to stick around to complete their masters, which is very impressive for a new program. But these are all available. I'll go into the details of computer science just because kind of looking at the sign up list, that's what everyone was saying that they were interested in. So I'll kind of go through the nuts and bolts of that. But I think one thing that you're going to see holds true with all of our programs is we have, I think, just the right balance of theory versus practice, right? theory is critically important because theory is one of those things that lets you sort of evolve your career over time. If you're great with fundamentals, then it doesn't matter what happens with programming languages or other technologies. Those can change every day, but you can learn them really quickly. At the same time, like I said, engineers are builders. And so in our programs, not only will you learn the theory, but you'll actually put it into practice in a hands-on fashion. And so that way, when you graduate and you go off into industry, you're going to be able to, on day one, actually start solving real problems in the professional world. So that's a big goal of ours. Um, what differentiates these programs? I mean, yes to all those programs, but really honestly, any program in the Fowler School of Engineering. Well, I would say that we're right-sized. So we keep our classes to 20, 30 students. You will get to interact with your professors. The instructors are also the ones that you will work with in office hours for meetings and whatnot. We do not have teaching assistants that are sort of the proxy instructor for our classes. The professors and the ones teaching the class are the ones that you'll deal with on a day-to-day. Certainly, we are not impacted in any of our engineering programs, so that means that you will be able to get your courses to graduate in 4 years. Does that mean I can promise you that you'll never have an 8 a.m. course or you'll never have class on Fridays? No, I cannot make you that promise. And I can't make you the promise that every semester you're going to be able to plan your perfect schedule and have a 3-hour lunch break. But it is definitely the case that our students here, as long as you hold up your end of the bargain on the academic side, you'll graduate in 4 years. I think the other thing that we really care about here is this notion of a teacher scholar. And so our faculty, regardless if they're world-class researchers, they are expected to be excellent in the classroom. That is something that's not negotiable for us. And so whereas in other universities, faculty sort of have this perverse reward system where sort of the more internationally recognized they get for research, the less time they have to spend in the classroom. That's not the case here. All of us, regardless of our rank, regardless of how widely regarded we are in our field, we still end up in the classroom teaching, whether that's freshmen or whether those are seniors or anything in between, because we really believe that to be a professor, you do indeed need to be professing, which is important. I think, like before I said, so many of our faculty do have industry backgrounds, myself included, and we continue to sort of keep a foot in industry in a lot of cases. I think that means that the programs that we build and as we evolve our curriculum, we keep that front and center. We're not interested in toy teaching tools or toy teaching problems. We're interested in helping you solve problems that are the type of problems that you're going to see in the industry, and you are going to solve those problems using the same tools that you're going to use in industry. And that's, something that's going to start in the first semester in Engineering 101 and go all the way until you're taking your upper division computer science courses like algorithm analysis and operating systems and so on and so forth. Along the way, if you want to get involved in research, you can do that and you can co-author papers with faculty. If you want to do internships, you can do that. Many of our students, by the time they're graduating seniors, they already have full-time employment lined up. But I think whatever you choose to do for your personal path, double majors, interesting major and minor combinations, dual degrees, integrated bachelor's plus master's. One of the things that you're going to find throughout is that we really do believe in human-centered engineering and human-centered education. And because of that, we believe in having a collaborative environment in our academic programs. We don't think that computer science programs need to be meat grinders where a third of your students don't make it through because somehow that's a badge of honor. It's not. Engineering should be for anyone who wants to study it. Computer science should be attainable for anyone who's passionate about it, and that's the way that we sort of run things here in the School of Engineering. Diving into the computer science curriculum, this is sort of what I was talking about, the fundamentals, right? And so if you look at our lower division coursework, you're going to see sort of a laid down bedrock that's going to last you for the rest of your careers, not just for your first job, but for the rest of your careers. So whether that's an engineering 101 where you're just learning to break stuff, or computer science 230 and 231 where we actually teach you how to think about programming and design programs, sort of not just learning a programming language, but how do you actually start to think about taking a complex problem, solving it computationally. These are all skills that are developed early on. And then you're also going to see that there's a fair amount of math as well, discrete math, and then a calculus sequence. And so the reason that we do that is because not only do we want you to be effective programmers, that's great, but also we want you to be able to reason carefully about the programs you're writing, understand how they're going to behave under different environments, understand how they're going to respond to different amounts of data that perhaps you run them on, right? And kind of a time when everyone has access to internet scale data and everyone's producing data at huge volumes, it's no longer sufficient just to say that you need to know how to program. If you want to be effective, you actually have to understand efficient ways to get computers to do your bidding. And I think that's really what differentiates a computer scientist just from a programmer. And so we really want to give you the foundation where whatever happens with programming languages for the next 40 years, you have the skills where you can keep re-upping and relearning what you need to be able to stay relevant. One of the things that is important for us is the idea of interdisciplinarity. And so all our computer science students take a 2-semester lab sequence. You can choose either biology, chemistry, or physics. There's a couple of reasons for this. Again, we think it's important to develop sort of those good lab skills that you would in a natural science. But two, now, obviously, computation is ubiquitous. And if you're a computer scientist, your skills can be put to work in pretty much any field imaginable. And even fields that are traditionally empirical, like biology, now rather than doing a lot of those experiments in a wet lab, it's done via computer simulation. So rather than being done in vivo, it's being done in silico. And that's true even now in physics, where we hear things about quantum machine learning and things of that nature and quantum computing. And so we want our computer scientists to, yes, be computer scientists, but we also want them to be scientists more broadly and engineers as well. And I think we managed to achieve that by sort of taking this very interdisciplinary approach to comp sci. Sort of moving into the meat of the program, we do, I think, some things that are interesting. First off, we have these colloquium requirements, which are 1-credit courses. I'll talk about those in a second. But also we have a very robust upper division core that you're going to see spans both hardware and software. So you'll understand things like digital logic computer architecture, because knowing how chips and processors works makes a huge difference when even when you're designing software and algorithms. But then you'll also learn about, how we can organize programs as efficiently as possible, how to make algorithmic choices that are going to make really hard problems computationally tractable, and then how we sort of cope with large volumes of data, whether that's sending it over the network or processing it on a computer using these wonderful chips that are now in our laptops that, have 32 cores and 128 gigabytes of memory, and how we store that data in things like relational databases or NoSQL databases in order to be able to find patterns in it. So hopefully you'll see that our program provides sort of different tiers. It provides this bedrock foundational levels when it comes to computing and algorithms. It provides this interdisciplinary across the natural sciences, and then it provides sort of these pillars in hardware, software, operating systems, database systems that then you can specialize further on. In terms of our programs, the thing that I'm probably most proud of, though, is these colloquium requirements. These are sort of 1-unit experiences. We call them low risk, big reward. They're 1-credit courses. You have to take 6 of them from computer science. They're graded pass, no pass. And so the idea is get you doing stuff that maybe you would typically only have grad students do, or perhaps stuff that's so bleeding edge that you couldn't justify a full course on it. And basically get you out of your comfort zone and know that as long as you show up and make an effort, it's going to be something that's not going to impact your GPA. It's just pure learning on your part, assuming that you take it seriously and show up. And so some example courses that we've run recently are things like using AI for software development, co-pilots and things like that. Machine learning in Minecraft, actually using Minecraft as a basis for learning machine learning and data science, space and launch systems for our students that are interested in aerospace and defense. Focusing on softer skills like developing your personal brand and being able to create a professional portfolio, and thinking about the marketing that you're going to do on your own social media to help you go out and get jobs. And then, just some really fun things like additive manufacturing, where you can use 3D printers and other technologies to go off and build and integrate computing into larger projects. And then a brand new one that we're running this spring, which is the mathematics of video games. So we're constantly offering new 298s. We're constantly rotating out 298s. And this is a way for us to listen to our industry partners and incorporate the bleeding edge into our curriculum, listen to our students and incorporate some of their feedback into our curriculum very quickly. And I think for us, provide a program that's not just the same old thing, right? Certainly there are things that you need to offer a computer science program so that it's actually a computer science program. But this is stuff that we do that I think makes our computer science program uniquely Chapman. And these 298s are actually built into all of our engineering programs here at Chapman. So if you come in as computer science and then you decide to change, let's say, to computer engineering, you'll still do the equivalent of these 298s. It's been a really wonderful reception by our students since we started doing this several years ago. And you know, I love building programs. I love designing curriculum, and I think that that looking back at my career, introducing the 298s into our programs is something that I'm going to be really proud of, and the students seem to really enjoy. In terms of specialization, we don't have tracks because we think tracks are a little bit binding. Some students want to be very, you know, sort of broad and they want to try everything. Some students want to specialize, but you will take 12 credits of electives. You can choose from any of these courses, including new courses that we're constantly creating. And so you can really own this degree and you can tailor it the way that you want to tailor it. If you want to do more hardware, you can do more hardware. If you want to do more human computer interaction, be more human centered in terms of your design, you can do things like assistive technology and human computer interaction and human factors. If you want to be sort of a more traditionally trained computer scientist, but get some experience with the software development lifecycle, you can do SE 300 and 310 and 320, which are all about the software development lifecycle. So in these 12 upper division electives, you really get to chart a course that's very much your own any way that you want to chart that course. And our students really like that. And so what that means is we don't take a cookie cutter approach to our computer science program. We want to make sure that people come out with a good solid core and enough exposure and enough depth to be able to keep evolving over the course of their career. But, you know, based on your own career ambitions, when you are leaving and you want that first job, then you can sort of use this upper division elective to tailor to the experience that you're looking for. Well, that's the curriculum, but if you're going to do the curriculum, you need to have a place to actually make it come to reality. And that's where Swenson Hall, our home, comes in to play. We moved in the fall of 2021. And Swenson really is what I would say is the embodiment of the engineering development life cycle or the software development life cycle, right? So when you walk in the door, there's an ideation zone where you can start designing your ideas and collaborating and thinking about how you can solve problems. For the most part, the space is always open to students, except occasionally for special events or rarely for a course. But for the most part, this is your space to use. You can then take that idea, and if it's something that needs to be integrated into a physical system, you can go off to the DCI lab, where it's basically a traditional maker space where you can create 3D print, you know, whatever it is that you're looking to do to hold your system using resin printers and traditional printers, and even this massive on the left, the Stratasys J850, which is just an absolutely incredible machine that allows you to 3D print using multiple types of colors and multiple layers and whatnot in a pretty seamless way. So our ability to do additive manufacturing, I would say, is impressive. These are all tools that, by the way, you can start using day one, and we encourage you to use day one. Hey, Eric, but it looks like the lower division coursework is, you know, building that foundation. So what's all this hands-on stuff? Well, Engineering 101, you will be in the makerspace. Grand Challenges Initiative, you will be in the makerspace. You just want to play around after class and be able to experiment building things and breaking things, you can go and do that in the DCI lab. So this is here for the taking, and it's open across the university. We're happiest when our computer science students and our electrical engineering students are shoulder to shoulder with business majors and theater majors and art majors designing and building cool stuff. We also have kind of that's the, you know, the clean side, the makerspace side. Here's the dirty makerspace side. It's basically a metal shop. So we have a CNC, water jet, band saws, everything that you would expect to be able to build something. Sort of when we designed the space, our goal was to say, well, if the students wanted to build a small CubeSat or maybe a small Formula One car, would they have the ability to do that in this space? And that's what we designed around. And then when you're done building, you can go across the hall to the tech shop, and this is where you can actually assemble everything and test everything. There's about $1 million worth of Keysight test equity equipment in there, all industry grade. There's a thermal chamber if you're interested in developing space systems and you want to know what's going to happen when things get hot. We have a thermal chamber for you to do that with. In general, we're a big fan of flexible spaces that allow folks to get their hands dirty, break stuff often, and then sort of learn from the experience, right? Typically, failure is something that people want to shy away from. A big part of being an engineer is failing and learning how to recover from it. And the Swenson Hall really provides a facility where from day one, not in year 4, but in day 1, your freshman year, you get to come in and you get to start learning these lessons the hard way by building things and then watching them break. And I think because of that, when our students graduate and they go and they do their interviews and then they get placed, they're able to come in with a very low learning curve and actually just start being computer scientists or engineers or whatever it is that they want to be. Okay. So that's sort of the nuts and bolts of it, but there's a couple of things that I wanted to say. Just because I get so many emails and so many questions, and sometimes people are afraid I'm going to be offended if you say it or ask it or whatever. So I just wanted to tackle them, just cut the BS and get right to it. So 1, ChatGPT is going to put computer scientists and software engineers out of work. So I shouldn't major in it. I should do something else because ChatGPT is going to do it for me. Absolutely not, right? In the same way that scientific calculators and graphing calculators did not put us out of work, right? ChatGPT is not going to replace computer scientists and software engineers. It's a disruptive tool and it's an efficiency multiplier, but it's going to be something that makes us better at our job. It's not going to take away our jobs. However, that being said, I feel relatively confident saying that in a very short amount of time, computer scientists and software engineers that don't embrace this technology are going to be much less competitive than computer scientists and software engineers that do embrace the technology and use it to make themselves better at their craft. But in terms of me, I spend absolutely 0 hours a day worrying about ChatGPT making me as a computer scientist obsolete. If anything, I just think it makes my skills in higher demand because everyone wants to take this technology and think about how they adapt it, evolve it, and apply it to their own domain problems. So I see this increasing demand for folks with my skill set, certainly not taking away from it. The other one is that people can't see, touch, appreciate the work that we do. Also not true. So this is right before I left Boeing to come to Chapman and be an academic. One of the reasons I sort of knew I was ready to move on is because I had a chance to work on a satellite system, a 702 SP. It was an all-electric satellite at Boeing. And it was an interesting sort of project because our goal was to be able to stack 2 of these things in a Falcon 9 rocket and launch them. So this was a comm satellite that we launched. And I was responsible for leading the team that wrote most of the code on it. So, okay, you say that you can't see code or you can't feel code. Here's this thing actually launching.
T-minus 10.
So with the system clock running, now with the clock running, at this point, this is when our software kicks on, and now the space vehicle and the satellites that we're launching are all completely autonomous.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff. GCOSN, proceed to section 10.66. Copy. Stage 1P, so
So that's not possible without software. Period. End of story. That's not possible without code. Now, is it the case that I print out code and show it to my friends, families, and loved ones? Probably not. I'd prefer them to think that I'm a little bit cooler than that. But certainly it is the case that you build things that people can see, people can touch. And I promise you, when that Falcon 9 takes off, if you're anywhere near it, you can absolutely feel it. The other thing that people say is, oh, well, computer science, it seems, I'm going to sit behind a computer and it's so sterile. I really want to make a difference. I want to make an impact. I want to help folks. How do I do that as a computer scientist or software engineer or data scientist? I honestly, when I started studying computer science, again, this first generation mentality was, well, it's going to be a good paycheck, right? I wasn't necessarily thinking about going off and impacting humanity. But getting back to my daughter, who I said was on the spectrum, when my daughter was diagnosed in 2012, I had this moment where I really had to ask myself, I have this PhD in computer science and machine learning. Now my daughter and kids like her are in a spot where, they really need effective intervention and treatment. I mean, now the rate of diagnosis of autism in the US is 1 in 36, right? So this is a growing problem. So what, could someone like me do as a computer scientist to try and help? And that was sort of a reason why I was ready to leave the industry world and come to academia, and start my research lab. And so I started MLab, the Machine Learning and Affiliated Technologies Lab. And a big part of the work that we do is actually, we're the dog's breakfast, but a big part of the work that we do is actually an autism spectrum disorder, trying to understand how we can make behavioral interventions more impactful. How, if someone has, let's say, 30 hours of insurance funding per week, if it turns out that they only need 25 hours, we can give them 5 hours back so they can go and read a book and do something fun rather than be in therapy, and help the insurance company use those 5 hours to give to someone else. Just in general, thinking about how we can help folks like my daughter be more included and be able to access the world, whether that's through education in their elementary school or their high school classrooms, or whether that's through technology online, or whether that's through just the ability to be in an environment that might typically cause sensory overload. And so for me, even though I'm a computer scientist by training, I consider my life's work outside of teaching to really be what I do with my lab, thinking about how we help folks on the autism spectrum. And so I do think, if I look at some of the things that we've been able to do, our work has been adopted by several insurance companies, by the California State Legislature, by the American Academy of Pediatrics, as sort of influencing funding models for kids on the autism spectrum, at least mostly kids on the autism spectrum. I do think this is an opportunity where, even though I'm a dyed-in-the-wool computer scientist, I feel like I've managed to have a really great impact. Now, certainly this did not come from a place of altruism in the beginning. It came from selfishness. It came from me wanting to help out my kid. That's really what it was. But I think now, being 10 years plus into it and looking back, I realized that as unexpected as my daughter's autism diagnosis was, it was the thing that led me to realize that as a computer scientist, I could actually have meaningful human impact, and that indeed actually computing is a field where you can leave this world a little bit better than when you found it. And I think that's absolutely, if ever there was a time when we needed the world to leave the world a little bit better than when we found it, now's the time. So I'm really grateful that I figured out how to do it as a computer scientist or as a software engineer. And I don't think that this is a fluke. I think it's something that's very easy to do if, again, you just sort of open your minds and your ears and maybe your hearts, and realize that opportunities will cross your path, and you just have to be brave enough to take them. Okay. So that's the end of my spiel. What do you want to know? What can I tell you?
I had a question regarding if there are any courses that specifically focused on natural language processing.
Yeah, so we cover it in a few different ways. It's absolutely included in our machine learning sequence and our AI sequence, sort of the traditional data science AI courses. We also have 298 courses that are focused on, we've done one on both traditional NLP and now, of course, large language models, right? For the most part now, when people say NLP, they're really talking about transformers and large language models. So we have all that. And then, of course, as part of our graduate program, our master's program, we have several courses on statistical learning and natural language processing that go even deeper into NLP. So as a senior, our students are taking some of those courses because, of course, ChatGPT is just so freaking awesome, right? How can you not want to learn more about it? So definitely very popular among our students.
Okay, thank you.
Yeah, of course. Other questions? Ask me hard ones. Make me earn my pay.
Also, the chat's open if you're too shy to come off mute. You can throw it in the chat and I can get that to Dr. Lindstedt.
I have a question. Do you have students that actually cross over between your computer science, computer engineering programs and the film school?
Yeah, we do. We see that happen in a couple of different ways. Occasionally we have students that actually do a dual degree. They'll do a Bachelor of Science in, let's say, computer science, and then a Bachelor of Fine Arts in film or something like that. We also have students that do that by having major minor combinations, either with like a major in computer science and then a minor over in Dodge College, or a major in the film school and then a minor over in engineering. Probably the most popular way of getting that crossover is through our game development programming minor. That's there are other ways to do it, but in terms of sort of the most density, if you go into our game dev classes, you will see a very good representation of engineers and film students all kind of in the same place.
Thank you.
Sure.
I had a slightly a different question. You mentioned ChatGPT is not replacing software engineering, but are you seeing any changes to the beginning of the job market where entry-level programming, et cetera, is kind of disappearing a bit, number one? And number two, are you doing anything, if so, are you doing anything different in your programs that's readying people to maybe be more editorial or anything to that extent?
Yeah, I wouldn't say that sort of the associate level software engineering jobs are disappearing, right? And in fact, I would say because of the AI hype, people are more excited than ever to get their hands on folks that can actually write good, solid code. However, I do think now, there is this expectation in industry that people, aren't necessarily starting from a blank page and they're using ChatGPT or the copilots as an efficiency multiplier. And so, now one of the things that we do in our courses is actually talk about, all right, how do you efficiently use a tool like Copilot, and how do you do prompt engineering to kind of get started writing code? And when it hands you code, how do you, actually make sure that it works? And how do you guarantee that it's the most efficient code that it could conceptually be? And then, some of our software engineering courses, we even get into stickier situations like, hey, you're writing code for an aerospace and defense contractor. You better make sure that that code that you just borrowed from ChatGPT can't get traced back to a source that's GNU public license, because now you've just made your entire code base open source, right? So we really, we embrace ChatGPT. I think a lot of schools, sort of their natural inclination is like, oh no, people are going to cheat. They're not going to, if they can't do it all from a totally blank page, then, what are we doing here? No, for us, it's a tool, and we want our students to be able to use that tool effectively. Certainly from, an academic perspective, we want them to give attribution, because that's just the right thing to do in terms of intellectual honesty. But also, it also gets to thinking about, how do I actually make sure that when I'm developing systems and I'm using code that's, whether that's back in the days when we just steal it from Stack Overflow, or whether now we're producing it from ChatGPT, sort of how can I be assured of the provenance of that code, be able to test it correctly, and be able to know in the case where you really do get a suboptimal solution that, this is giving me code that's running in quadratic time, but anyone who has exposure to algorithms should know that I should be able to solve it in n log n time. So that's something that we have absolutely sort of adapted to in our curriculum.
Sorry if I missed this earlier, but do you have a co-op program or internship program?
We have I wouldn't say we have a single program. So what we do have is a director of industry relations, and that industry relations director, along with our career services manager, is basically constantly responsible for building partnerships with industry and then connecting industry with our students. And so students do that in a variety of ways. Still the traditional summer internship is very popular. We see students that do co-ops, and especially in their senior year, they're sort of splitting their time between being on campus and doing and working. Now micro internships are also starting to get really popular. These are, very sort of like short targeted experiences. And so we're even seeing students that are doing, let's say, these 6-week micro internships over the summer, or perhaps over interterm and a little bit into spring semester. So yeah, I think our goal is that by the time our students graduate, we would like as close to 100% to have either completed an internship or a research rotation in the lab. And I think right now we're in the low 90%. Sure.
Can you speak more to research opportunities and the research rotations you just mentioned?
Yeah. So, Chapman's a primarily undergraduate institution. We certainly have some master's and PhD programs, but for the most part, of our 10,000 students, over 7,600 are undergrads. And so the majority of our faculty, when it comes to doing research mentoring, it typically is with undergraduates. And really, the goal in Fowler is to tear down the walls that keep undergraduates from being able to get involved in research. And so one advantage of having small classes and actually getting to know your professors is you can learn about their research and you can be, very bold. And we have students that their first semester approach us and say, I would like to do research with you. Depending on what their preparation is or what their skill sets are, what their interests are. Sometimes it's like, great, come and start working. Other times it's, hey, get through data structures and then you can come and sling some code with us. But yeah, I would say that it's not hard for students to get involved. And we have a lot of students that graduate and they're co-authors on peer-reviewed journal articles or presenting posters at international conferences, which is pretty cool. And I'm especially happy when I see students that are collaborating with researchers outside the School of Engineering, because especially for something like computer science or data science or software engineering, it is so interdisciplinary, right? So it's wonderful. Yeah, okay, not surprising that you're going to see a computer science student maybe doing undergraduate research with a physicist or a biologist, but really cool when they're working with, let's say, an archaeologist studying human habitation of the International Space Station, or working with a law professor to be able to find sort of legal trends that have happened over the decades as it pertains to technology and other things, or working in the humanities to analyze war letters, letters that have been written by troops when they're overseas for a variety of conflicts, and sort of seeing the themes that emerge from doing that. So it's not hard to get involved in research at Chapman, certainly not in the School of Engineering. I think that the bigger problem is students start and they're like, it's like being in a candy store, right? Everyone wants to do everything. And it's like, okay, pace yourself. You have 4 years, get your legs under you, figure out what your interests are, what your priorities are, and then strategically engage. That being said, probably half the students ignore me, and their first semester they're busy. They're busy joining clubs and doing research and playing sports and all that good stuff all at once.
For the machine learning and AI courses, does that like go into the math and like neural networks of like how that works?
Yeah, I mean, it's also just the it's the it's one, sort of the actual approach, the bio-inspired approach, like you mentioned, neural networks, right? So why do artificial neural networks sort of look the way that they look? How has that been inspired by our own understanding of the human brain? But obviously, they're an approximation, right? And so we talk about the math that's used in, let's say, an artificial neural network, whether we're talking about a standard sort of feed-forward neural network, or we're talking about a convolutional network, and then talking about the mathematical assumptions and what that gets us and what we lose from it. Because a lot of the things that we do in, let's say, neural networks in particular, we're doing it for, one, mathematical convenience, and two, for computational efficiency, not because it's as high fidelity as it could be to what's actually happening in the human brain. So we try and go through all of that. And I say that we take a spiral approach. We start touching on it in the beginning courses and then go deeper and deeper and deeper as we go throughout the curriculum. But yeah, in general, if neural networks are your jam, then yeah, then the math is something that's going to become a near and dear friend to you.
Cool. Thank you.
Anything else?
Just threw in the chat engineering@chapman.edu. So if you, for some reason, think of a different question in the middle of the night, we're more than happy to get back to you with that answer. If you don't want to come off mute or put in the chat, that's fine too. We are pretty good at responding to the email within like a 24-hour period. So you can shoot it our way if you need to.
Absolutely. I guess one more time, any other questions, easy questions, hard questions,
Random questions.
random questions? If you want to talk about other schools you're looking at, I can make disparaging comments, really whatever makes you happy.
Also, if you haven't visited our wonderful home and you'd like to visit and take a tour, also engineering at Chapman, if you want to sign up for a special Swenson tour, we do offer through the university Keck Center tours, which is our entire building for science and engineering. But if you wanted to do kind of this back, kind of a special tour, you could just email engineering@chapman and request that.
Definitely. Okay. Well, Adina and I will hang on just a little bit because we know there's always a few shy folks that want to wait until other people disperse. But otherwise, thanks so much for joining. You have our contact information. Don't be shy. Thanks for letting me ramble a little bit about myself and my own personal story, in addition to sort of the way that we approach computer science here. But hope to see you on campus, either as a visitor or as a student. And when our paths cross, make sure to shout at me and come say hello.
Yeah.
Here,
Thank you.
everybody. Have a good rest of your
Thank
day.
you for joining.